All right, ladies and gentlemen, this is going to go through our laws of exponents. I'm going to go through all 6 laws in this video. So as I'm going through, if you need to fast forward to the law that you want to learn about, go ahead and fast forward now to the law that you want to learn about. You'll always see what law I'm talking about because it'll be right there on top at the screen. Let's dive in. Law 1. Law 1 says when we are multiplying two terms with the same base, x and x, we keep that base and we add the exponents. All right, well, why do we do that? Let's take a look at what it really means in expanded form. And it's always good to understand expanded form, and I'm going to show you all the expanded forms in this video because it's something that you can always go back to and do on your own if you forget the law and you need to just figure out what it is. In this case, x cubed means x times x times x, and x to the 5th means x multiplied by itself 5 times. And if I'm multiplying these two together, I'm really just multiplying all of these x's together, and that's a total of 8 x's that I'm multiplying all together to begin with. And that's what we see. If the expanded form here represents multiplying 8 x's together, then x to the 3rd times x to the 6th is equal to x to the 8th. And that's where we get our law from. Let's use it. All right, let's take a look at this first one. X to the 10th times x to the 12th. Well, I'm going to keep my base and add my exponents. 10 plus 12 is 22. Let's look at the next one. Y times y to the 9th. Careful, the answer is not y to the 9th here because the first exponent's a 1, and 1 plus 9 is 10. We're multiplying 10 all together. What if I put both x and y in there? Well, if I put both x and y in there, do x first, y second. X to the 3rd times x to the 1st gives me x to the 4th, and y to the 4th times y to the 5th gives me y to the 9th. Let's take a look at a few more examples here. Feel free to pause the video, see if you can do it on your own. All right, if you're coming back in from a pause, let's see how you did. All right, now I've added in some coefficients here. The coefficients are not exponents, and therefore you do not apply the laws of exponents. Due to the coefficients, what the operation is telling you to do. In this case, example 4, 3x times 5x. You've done that a lot. 3 times 5 is 15. And x times x, we're going to keep the base and add the exponents. This is really a 1 and a 1, giving me x squared. You've actually seen 3x times 5x before when we're multiplying binomials. Now you're understanding why x times x is x squared. Let's take a look at number 5. Again, our coefficients of 4 and 10 are not exponents. Multiply them as the problem's telling you. 4 times 10 is 40. Now apply laws of exponents to our terms with exponents, or our pieces with exponents, rather. Keep the base, x. 5 plus 7 is 12. All right, so look at our last one here. Again, 2 and 7 are our coefficients. Multiply them as the problem tells you to, giving you 14. But now deal with your m's. M to the 1st times m to the 8th is m to the 9th altogether. N squared times n to the 15th is n to the 17th altogether. That is law 1. Take a look now at law 2. Law 2. X to the 8th over x to the 5th. Well, x to the 8th means 8 x's on top being multiplied together. All right, there's 8. And x to the 5th means 5 x's on bottom being multiplied together. If I wanted to simplify this fraction, what could you do to simplify? Well, I noticed that every x over itself makes a giant 1. So 5 x's over top of 5 x's also makes a giant 1. And when I do that, these all become 1, and on top I end up with x cubed, and on bottom I end up with 1, not 0. Again, this simplifies to a 1. All right, and x cubed over 1 is just simply x cubed. And so that we see that x to the 8th over x to the 5th is x cubed. We notice that we kept the base, but this time I subtracted the exponents, top minus bottom. That's what our law says. Over here, when I see x to the a over x to the b, it says keep the base of x and subtract the exponents, top minus bottom, a minus b. Let's apply it. All right, w to the 5th over w squared. Well, I'm going to keep my base of w. 5 minus 2 is 3. Done. Try 2. All right, if you tried 2 now, if you pause the video, coming back in, x to the 21st over x to the 19th, I'm going to keep my base of x, and I'm going to subtract 21 minus 19 is 2, giving me x squared. Let's take a look at 3. Now all of a sudden we've got x and y, just like in law 1. We're going to do both of them just separately. Start with your x's. Keep the base of x. 6 minus 3 is 3. All right, then go to your y's. Keep the y. 2 minus 1, because we don't see an exponent there, 2 minus 1 is 1. And I'm not going to write that 1 because I don't need to write an exponent of 1. But I get x cubed y. What do you do in this next one here? Take a look. Try it. All right, well, in this case here, again, keep the base. But 5 minus 9 is negative 4. Negative 4 is allowed. We'll talk about what a negative exponent means when we get to law 5. Let's take a look at the next one. All right, now all of a sudden I've got coefficients. Coefficients, 12 and 3. Treat them just like a fraction. 12 over 3 is 4. All right, now deal with your variables. X squared over x to the first, keep the base, subtract the exponents. 2 minus 1 is 1. My y, I have a y on top and nothing on the bottom, so I'm just going to keep it as y as is. All right, let's try our last one. Try it on your own here. All right, coming back in. Treat this as a fraction, 10 over 15. That is 2/3. All right, and then let's do our subtraction here. M to the third over m to the fourth, that's m. 3 minus 4 is negative 1. And then now my n's. N to the 7th over n to the first, 7 minus 1 is 6. An alternate way to write this one here, should you want to do that, is to have 2n to the 6 on top and 3m on the bottom, because really I've got 2 in the numerator along with my n's because there were more n's up top, and I have 3 in the denominator along with my m because there were more m's on the bottom. We're going to see just what that means and how that works again when we get to law 5. All right, let's take a look at law 3 now. When we're taking an exponent to another exponent, well, we have to ask ourselves what that exponent means and what it's telling us to do, particularly this exponent here of a 3. All right, now that 3 is next to the parentheses. That means it's referring to our parentheses, so I'm really looking at x squared times x squared times x squared. All right, which if I expand that even further is x times x times x times x times x times x. And that is multiplying 6 x's all together. All right, so we notice that x squared to the third is x to the 6th, showing us that if we're taking an exponent to another exponent, we multiply those exponents and keep that base. That's law 3. Let's put it into practice. Take a look at number 1 here. So x squared to the 4th, keep the base of x. 2 times 4 is 8. All right, try number 2 on your own. All right, in this case here, keep the y. 5 times 6 is 30. What if I have more than one variable? Well, it doesn't matter. Just do both of them. Start with x cubed, so keep the base. 3 times 2 is 6. And then go to y. Keep the y there. 4 times 2 is 8. We just apply that exponent to both pieces inside the parentheses. All right, let's add in some coefficients. Now, if we've got a coefficient 3, keep in mind that squared is referring to every single piece in here, like the distributive property, but this is not the distributive property. Distributive property refers to multiplication. It's very similar, though. In this case here, I'm going to end up with 3 squared and x to the 6th squared. I got to do it with both. Well, 3 squared is 9, all right, and then x to the 6th squared, keep the base. 6 times 2 is 12. All right, try it for number 5. All right, 4 cubed. All right, 4 cubed in this case is 64. All right, now x, that's x to the first, so 1 times 3 is 3. And then y to the 4th cubed, 3 times 4 is 12. What if I've got a fraction? Well, if I've got a fraction, I still do everything to the fraction just as I would if it weren't a fraction. In this case here, start with my 2. 2 to the 5th is 32. And then x to the 8th to the 5th, 8 times 5 is 40. Over on the bottom, 3 to the 5th. If you go ahead and plug that into your calculator, you get 243. I don't expect you to have that memorized. And then deal with your y's. Y to the 5th is going to be 5 times 5 is 25. And that's our final result there for law 3. All right, let's take a look at law 4 now. Law 4 derives itself from law 2. So a brief refresher of law 2 is right down here. All right, law 2 here says that when we have two exponential terms being divided, we keep the base and subtract the exponents. Let's go ahead and apply that here. Now, when I do that here, I see that I keep the base of x, but 4 minus 4 is 0. And we get a unique situation. What does a 0 exponent really mean? Well, to understand what it really means, we're going to look at a few different ways. First off, let's expand it out. X to the 4th over x to the 4th. Well, that means x, 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 x over x, 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 x. Well, that makes a giant 1 when you have the same number over top of itself. Therefore, this reduces down to 1. Well, if the expanded form is equal to 1 and the simplified form using law 2 is equal to x to the 0, then the transitive property of equality says that x to the 0 must equal 1. And that's exactly what my law is. It's saying anything to the 0 exponent is 1. Let's understand that a little bit further. What does 3x squared really mean? Well, 3x squared means 3 times 2x's. Remember, the exponent of squared only applies to what it's directly next to, and therefore just the x in this case. What does 2x squared mean? Well, 2x squared means a 2 times 2x's. So what does x squared mean? Well, x squared means 2x's, but what's it being multiplied by? I was multiplying by 3 and then by 2. Well, when you don't see a coefficient, it's a 1. Well, that means it's a 1 times 2x's. That's x squared. So what's x to the first? Well, again, the coefficient being a 1, that means 1 times 1x. So what's x to the 0? Well, again, the coefficient being a 1, that means a 1 times no x's. All right, and therefore, we end up with just 1. Once again, seeing that x to the 0 is equal to 1. Anything to the 0 exponent is 1. This is actually one of the easiest laws to apply. Let's take a look here at example number 1. 4x to the 0. Again, the 0 exponent only applies to what it is directly next to. So in this case, this would be 4 times 1, or just 4. You can rewrite it without the x's because they're saying there should be 0 x's. Look at the next one. Well, this is just 3x squared times 1. Well, that's just 3x squared. Again, you can just rewrite it without the y's. Look at the next one. M to the 0 means write it without the m's. So it's just going to be 5m. All right, let's get to a little more complicated examples here. All right, xy to the 0. A lot of people mess this up. A lot of people say 1. Well, that is not true. The 0 only applies to the y. So therefore, you're left with x. What about this one here? 3x squared, y to the 5th. You could look at applying that 0 to all of them and then plugging it all in, but anything to the 0 is 1. The 0 here is applying to the entire group because it's right next to the parentheses, so this entire thing becomes 1. And even in number 6, this one looks really, really complicated, but the whole thing is being taken to the 0 exponent, so the whole thing simplifies to 1. That's Law 4. All right, here we go for Law 5. Law 5 also derives itself from Law 2. So again, a refresher on what Law 2 is. That is x to the a over x to the b. When I'm dividing two terms with the same base, I keep that base, subtract the exponents top minus bottom. Let's apply that here. X cubed over x to the 7th. Well, I'm going to keep the base. 3 minus 7 is negative 4. We saw this before when we examined Law 2, and I told you that we'd come back to what a negative exponent means, and that's where we're going to see it here. Let's expand it for a moment. X cubed is 3x's on top. X to the 7th is 7x's on bottom. If I were to simplify that by creating a giant 1 out of my first 3 x's, this then simplifies to 1 over x to the 4th. It's not a 0 on top. Again, that's a giant 1, so it's a 1 on top. Well, again, through the transitive property of equality, if x cubed over x to the 7th is equal to x to the negative 4th, and the expanded form is equal to 1 over x to the 4th, then the transitive property of equality says that x to the negative 4th must equal 1 over x to the 4th, showing us that a negative exponent merely means that the value it's referring to should be in the denominator. That's the first part of the law. If I have a negative exponent, I'm just going to shift it down to the denominator and make that exponent positive. Well, if that's true, then the reverse of that is also true. What if I have a term in the denominator already with a negative exponent, as I see here with negative a? Well, that means that I'm simply going to shift this to the numerator and now make the exponent positive. A negative exponent means that it's in the wrong spot and it could be moved to be rewritten. I say rewritten and not simplified because technically both versions would be simplified. They're just two different ways to write it. Let's look at example number 1. X to the negative 4th. We just saw that one. If I want to rewrite that, I could rewrite it as 1 over x to the 4th, moving it to the denominator and making my exponent positive. Take a look at number 2. Negative exponent in the denominator, I could rewrite that as x to the third. That one would be considered simplified. Something to note, you shouldn't really finish a problem with a negative exponent in the denominator. It's like writing negative 3. When we do 2 minus negative 3, I really don't want 2 minus negative 3, two negatives. I'd rather just have it plus 3. It's much simpler that way. In the same way here, if you have a negative and it's in the denominator, it's so much simpler to just write x cubed. This is simplified. However, in example 1, as I said, either one of these could be considered simplified. Let's look at example 3. Let's rewrite it. Now, the negative exponent here is only applying to the x. So if I rewrite it as a fraction, that x is going down below and becoming a positive 2. Everything else that was up top stays up top because it doesn't have a negative exponent. That's how I rewrite it. Let's take a look at this one. Now, all of a sudden, x squared z over y to the negative 8th. The negative exponent is on the 8. I want to move it up. The x squared stays up top. But the y comes up top and makes that negative 8 a positive 8. And the z stays up top. Notice I wrote it x, y, z. That's alphabetical. You should write your variables in alphabetical order. Let's take a look at the next one. In this case here, I've got two negatives. The n has a negative 1 and the m has a negative 6. My 8's going to stay up top. That doesn't have a negative exponent. However, that n to the negative 1 is going to go down below and the m is going to come up top. Notice I turned both exponents now positive because I moved them to where they belong, and therefore I can write them like that. An alternate way to write this would be m n to the 6th, n to the negative 1st. That would also be considered simplified. Both of those would be acceptable here. We don't want to leave it the way it originally was, though, because we have a negative exponent in the denominator. Take a look at our final one here. In this one, it's a little bit of a challenge, but we have to recognize the number that we're dealing with. First off, we've got a 1 on top and a 2 on the bottom. That's my fraction, 1/2. 1 on top, 2 on bottom. Now let's deal with our exponents that are negatives. X to the negative 3rd means move it down below, make your exponent positive. Y to the negative 4th means move it down below, make the exponent positive. That is how we apply Law 5. Law 6 is not going to be on your PSSA exam. You will not see it on Keystones. You won't see it anywhere like that. However, we do teach it as a law because it is something that will become useful as you head to high school. All right, and when we deal with Law 6, it allows us to rewrite roots in order to have them be exponents so that we can apply the other laws of exponents to them. It makes it so much easier when it comes to simplifying some things. So let's take a look to understand what a fractional exponent really is. If you take in your calculator and you plug in the square root of 9, you'll get 3. If you also take in your calculator and you plug in 9 to the 1/2, which you'd have to do like this, 9, and then use that caret 1/2. That's how you'd have to plug it into your calculator. And if you do that, you find that you also get 3. Now the cube root. The cube root can be found in your calculator under the math section. When you get the cube root of 8, you'll see that it's 2. And if you plug in 8 to the 1/3, you'll see that you also get 2. And from the transitive property of equality, we see that if the square root of 9 is equal to 3 and 9 to the 1/2 is equal to 3, then the square root of 9 must equal 9 to the 1/2. Likewise, the cube root of 8 must equal 8 to the 1/3 because they both equal 2. That's the transitive property of equality. Well, if that's the case, where do these fractions come from? Well, take a look at what was originally on our numbers. 9 originally had an exponent of 1. And we are taking the square root, which is assumed to have a 2 out front because it's our square root. Well, the 1 became my numerator, and the 2 became my denominator in my fraction. Take a look at the next example. We had 8 to the 1st and the cube root. Well, the 1 became the numerator in my fraction, and the 3 became the denominator in my fraction. All right? So we see in our law that the numerator stays up top there. The exponent that was originally there becomes the numerator. And what I'm taking the root of, my root value, becomes my denominator in my fraction of the exponent. Let's take a look at rewriting a few here. All right, so the square root of x, remember, the square root is a 2. We don't have a first root. We don't deal with that. And no exponent on the x means a 1. So this is x to the 1/2. Let's take a look at number 2 here. This is a 3. Make that a little bit more clear. All right, cube root of x to the 4th. Well, keep the 4 as the numerator and make the 3 my denominator. All right, take a look at this one. Just apply it to both. keep the 5 as my numerator and make the 4 my denominator. And in the y, keep the 1 as my numerator and make the 4 my denominator. An alternate way to write this would be taking the entire group to the 1/4. That'd be another way to write it as well. Let's take a look at a few examples going the opposite direction. To the 1/5. Well, I'm going to keep the numerator as my exponent, which I don't need to write a 1. And my denominator is going to be my root value. So I find that's the 5th root of x. Take a look here, 7/3. Keep my numerator as my exponent and then make the denominator my root value. So put a tiny 3 above that little root part, making it the cube root. And this last one, I'm taking 1/3 to the entire group. So that means the entire group is going to be to the first power. And I'm going to put it under a cube root, making my denominator the root value. And that is how we apply Law 6. Or that's how we use it to rewrite things. Now, why would you want to do that? Let's take a look at a few examples for that. What if I asked you to simplify this one here? Well, it looks a lot like Law 1. However, I've got a root value involved, and so that makes things a little bit trickier. However, if I apply Law 6, I can rewrite this as x to the 4/3. Now when I multiply times x to the 6, I see it's Law 1. I keep my base, and I can add my exponents. Now keep in mind, 4/3 plus 6. We're going to have to keep thirds in mind here, so it's really 4/3 plus, if I look at this, that's 18/3. That's one way to go about it. Another way you could do is you could see it as just 1 and 1/3 plus 6, which is going to give me 7 and 1/3. All right. If I do this here, I get 22/3. I find that these are the same. If you go this route, which is a little bit easier, you're going to have to convert 7 and 1/3 back into an improper fraction here at the end. All right. But I end up with 22/3, or I end up with the cube root of x to the 22. But there's a simpler way to write that, and that's what I want to show you here as well. Using Law 6, I can also simplify what's going on here. Let me just move this over for a second. Instead of leaving this as the cube root of x to the 22nd, I can pull out the x's that make this a little bit easier here. I know that in the cube root of x, every time I find x cubed and the cube root, they're going to undo each other, and that's going to give me x. So in this case here, I could take time and I could, as we've seen before, write the cube root of x times the cube root of x times the cube root of x, and I could keep going till I get 22 x's all the way out there. But that's going to take a lot. That's going to give me 7 of these x cubes and 1 x left over. All right? But there's a simpler way to do it. Instead of simplifying going that route, I could identify that being that 22/3 is 7 and 1/3, that means that the cube root of x to the 22nd could be rewritten as the cube root of x to the 21st times the cube root of x. Now, what does that really tell me here? Well, that really tells me that I've got x to the 7th times the cube root of x. Why? Well, that's because this here can be rewritten as 21/3. 21/3 is 7, or x to the 7th rather. Because if I come back to the 7 and 1/3, that means I have an x to the 7th and an x to the 1/3. All right? So the x to the 7th is here, and the 1/3 is just saying it's the cube root. Let's take a look at a few more examples just to make this stand out a little bit more. All right, what if I asked you to simplify this? Well, if I look to simplify this, I see that it's got some root values, but I can apply Law 6 to rewrite it. So I got 11/2 times x to the 9/2. Law 1 says keep the base, add the exponents. Well, that's going to give me 20/2. And that could be written as the square root of x to the 20th, but there's an easier way to do it. Just simplify your fraction. 20/2. What's 20/2? Well, 20/2 is 10. So I just end up with x to the 10th. Let's take a look at another example. What if I have the square root of x to the 5th y times the square root of x to the 6th y cubed. All right, let's simplify this here. All right, if I simplify it, I simply have x to the 5 halves, y to the 1 half, times x to the 6 halves, y to the 3 halves. All right, and as I go to simplify these together, I'm going to keep my base and add my exponents. 6 plus 5 is 11. All right, and over here, 1 half plus 3 halves is 4 halves. Now, if I were to simplify this, this comes down to 11 halves. That is 5 and a half for my x's. All right, because I can get 2 going into 11 5 times with 1 half left over. And y, well, 4 over 2 is just going to be 2. That means that this goes all the way down to x to the 5th y squared times the square root of x, because this 1 half says it's the square root of x, and all the rest comes out of that root. That's how you can use Law 6 to simplify some things, and that's where it's really going to go.